At the heart of nearly every large galaxy lies a sleeping giant, a supermassive black hole holding millions or billions of solar masses. Our own Milky Way harbors Sagittarius A, 4 million times the mass of our Sun. In galaxy M87, the central black hole reaches 6.5 billion solar masses. Since the 1990s, observations have confirmed this pattern across the universe. Almost every large galaxy hosts a supermassive black hole at its core. The mass of a galaxy and the mass of its black hole are tightly linked. This correlation suggests they grew together, co-evolving over billions of years. Yet theorists had long imagined an extreme possibility. Under rare conditions, a black hole could be ejected, escaping its own galaxy entirely. Since the 1970s, this idea existed only in equations. No observation had ever confirmed it, until now. In 2023, astronomer Pieter van Dokkum was scanning Hubble Space Telescope images. He noticed something that had no right to be there. A razor-thin streak of light extended from a galaxy 8.8 billion light-years away. It stretched 62 kiloparsecs, roughly 200,000 light-years, into empty space. The team's first reaction, a camera artifact, a flaw in the data. But the streak reappeared across multiple independent observations. Inside the structure, something extraordinary was happening. Young, newly formed stars lined its entire length. Something had plowed through the gas at tremendous speed, compressing it into stellar nurseries stretched across 200,000 light-years. The question was no longer whether the streak was real. The question was, what could possibly leave a trail like this? At the end of the stellar streak lies a cosmic collision. Two ring galaxies, 8.8 billion light-years away, merging into one. Astronomers call it the cosmic owl. Twin galactic rings caught in the slow violence of gravitational merger. Deep within the chaos, 3 active galactic nuclei were detected. 3 supermassive black holes orbiting the same catastrophic event. As 2 galaxies fused, their black holes spiraled inward. A third was observed separating, ejected from the system entirely. Van Dokkum's team proposed the runaway black hole hypothesis. The scientific community challenged it. A tilted galaxy, a shredded remnant. The streak's origin point pointed unmistakably toward the cosmic owl. Something had been violently expelled, and it was heading away. In December 2025, the James Webb Space Telescope locked onto the tip of the mysterious streak. NIR spec began capturing the most precise spectroscopic data ever obtained on this structure. The micro-shutter array opened its 248,000 tiny doors, isolating light from the streak's tip. Spectral data streamed in, and something in the numbers looked deeply wrong. At the tip, the radial velocity shifted by 600 kilometers per second across just 1 kiloparsec. Only one thing in the universe could cause a discontinuity this sharp, a supersonic bow shock. The calculations confirmed it, an object moving at 954 kilometers per second, mass exceeding 10 million suns. RBH-1 had been named, the first confirmed runaway supermassive black hole in history. Van Dokkum's team submitted their findings to Astrophysical Journal letters. A 50-year-old theoretical prediction had finally been observed for the first time. The discovery rippled across the scientific world, but RBH-1 itself moved on, indifferent, blazing through the void at 3,000 times the speed of sound and accelerating into eternity. For 50 years, this was only theory, a black hole flung from its own galaxy by the violence of collision. When two galaxies merge, their black holes spiral inward, drawing closer across millions of years. At the final moment, they collide, and the universe itself shudders. The merger is never perfectly symmetric. Gravitational waves burst outward unevenly, and the recoil launches the merged black hole like a cannon shot. Jacob Bekenstein predicted this mechanism in 1973. RBH-1 is its first direct confirmation, 52 years later. RBH-1 now travels at 950 kilometers per second, 3,000 times the speed of sound. Behind it stretches a 200 light-year trail of newly born stars. As it tears through the intergalactic medium, it compresses gas into stellar nurseries, a 10 million solar mass black hole, alone in the void, yet still creating life. The shape of the bow shock told a precise story. Astronomers modeled the gas velocity field against standard shock equations. The calculation was unambiguous. The object was moving at 950 kilometers per second, 3,000 times the speed of sound, with an uncertainty of just 120 kilometers per second. Its trajectory was inclined approximately 30 degrees to the line of sight. The black hole was not heading away from us. It was cutting across the cosmos. Energy conservation applied to the 200,000 light-year stellar trail confirmed the mass. At minimum, 10 million times the mass of our sun. Van Dokkum's team gave it a name, RBH-1, Runaway Black Hole 1, the first of its kind ever confirmed. Van Dokkum's team gave it a name, RBH-1, Runaway Black Hole 1, the first of its kind ever confirmed.